Okay, hello everybody. I'm just gonna test out Zoom here, and I'm also testing out this new drawing tablet that I have, which will hopefully help me work through some problems with you guys as they come up. So to test this out, I'm just gonna go over something that we had at the end of our last lab, which was before the midterm, and that was finding the current in a circuit that had an LED in it. And an LED is a light emitting diode. So we had a red LED and a resistor and a voltage source hooked up at the end there. So I'm going to try to share my screen. Hopefully this shows up on the recording. And we'll test out this new drawing tablet I've got. So what we had was a voltage source. And this was Vs, and I believe it was 12 volts. And then we had that connected in series with a resistor, and that resistor had a value of 1 kilo ohm. And that was connected to our LED. And that's our schematic symbol right there for a diode. And then when I add these two arrows, that means it's an LED. And what we used was a red LED. So if you remember, different LEDs are made out of different materials. So if we have red LED versus yellow, orange, green, blue LED, they're going to have different voltages because they're made out of different materials. So that's our VD for our diode voltage, since it's an LED, light emitting diode. And then we're also going to have a voltage here for our resistance. So it's also going to have its voltage drop, VR. All right, so what we were interested in was this current, I, and that's going to be going through this voltage source, going through this resistor, and also going through this LED, because all of those are connected in series, so they share the same current. Okay, so how we find that, we can't find it using Ohm's law, because we can't use Ohm's law with things that aren't resistors. So no Ohm's law with diodes. They are not linear components. They don't respond the same way, so we can't actually use Ohm's law directly. But we can use properties of circuits, because we know that the same current that's going through this diode right here is going to be the same current that's going through this resistor. So if we know the voltage across that resistor, we know its value, it's given as 1 k ohm, so then we would know the current going through there, and we know the current going through the diode. Okay, so how do we find VR? Well, we know what the voltage source is, 12 volts, and since this is a forward biased diode, that's going to get a certain voltage, right? So when you measured that voltage in the lab, what you should have seen for that diode voltage was somewhere around 2 volts for a red LED. So let's say that we got 2.1 volts for that red LED, and that's what we measured while it was illuminated. So then we know what this voltage is, we know what this voltage is, and by Kirchhoff's voltage law, we can find VR, because what the supplied voltage is here has to equal the sum of the drops in the circuit. So VR, the voltage across that resistor, plus VD, the voltage across the diode, has to equal what's supplied, which is that 12 volt Vs. Okay, so we just want to rearrange this a little bit. So we have VR is equal to Vs minus VD, which we get by subtracting VD from both sides. And then we can come back over here to our current equation, which is VR over R. And then we can substitute in what we just found here. That's a bad circle, so circle that a little bit better. And we're going to substitute in Vs minus Vd divided by R. Okay, so we know what Vs is. That's 12 volts. We can subtract what we measured for the diode voltage, which should have been somewhere around somewhere between probably 1.8 to 2.2 volts for a red LED. So let's say that it was 2.1 volts, and we divide by 1 kilo. Okay, so on top we're going to have 9.9 volts divided by 1 kilo. And if you remember, when we have volts divided by kiloohms, we're going to get an answer in milliamps. So we actually have just 9.9 milliamps for the current that's going through that diode. Okay, hopefully that made some sense.